Today, let us see the demonstration for Newton's law of motion. Part 1. The apparatus required for the first experiment is a beaker, sand, a card sheet and a coin. Let us demonstrate the experiment. First, take some sand in the beaker, then place a card sheet on the beaker. Now place a coin at the center of the card sheet. Now strike the card sheet with a flick of your finger. Wow! What did you just see? The card sheet flicked away, but the coin fell in the beaker. So students, what inference can you draw from the experiment? By which virtue did the coin not go away with the card sheet? Yes, correct. It is inertia. The experiment just demonstrated Newton's first, that is, law of inertia. The sudden movement was given to the card, which was flicked away, but the coin continued in the state rest of inertia. That is why it fell in the beaker. Thus, the experiment beautifully demonstrates Newton's first law of motion. Part 2. Now, let us perform the second experiment. The apparatus required for the second experiment are a metal and a wooden block of same size, a flat container, soil and water. First, mix soil and water in flat container. Keep this container near the legs of the table. Now push the wooden and metal blocks of the same size in such a way that they fall into a flat container. Now observe the impressions created by the blocks in the soil mixture. So students, what inference can you draw from the experiment? You can observe that the impression created by a metal block is deeper than that created by a wooden block of the same size. What do you think may be the reason? As you know, though the size of two blocks are the same, but the metal block is heavier than that of wooden block. Therefore, the impact produced by the metal block is more than that of wooden block. The force is directly proportional to the mass. As in this case, gravitational acceleration is the same. The above experiment thus demonstrates Newton's second law of motion. Acceleration of the object is dependent on two variables, the net force acting upon the object and the mass of the object, that is, F is equal to mass into acceleration. Part 3. Let us perform the third experiment. The apparatus required for the experiment is a balloon, a piece of rubber pipe having a diameter of 5 mm to 1 cm. To start with, let us tie a balloon tightly to a lightweight rubber pipe. Now, inflate the balloon by blowing the air through the rubber pipe. Tightly close the end of rubber pipe by pressing with the finger. Without removing the finger, place the balloon carefully on the flat surface. After a while, remove the finger. What did you observe? The balloon, while deflating, moved forward. So, what inference can you draw from the experiment? The air which was coming out of the balloon in the backward direction pushed the balloon in forward direction. This experiment demonstrates the third law of motion, that is, to each and every action there is equal and opposite reaction. Here, the air coming out of the balloon can be considered to be action, which produced a reaction force on balloon to move it in a forward direction. Thus, the force always appears in action and reaction pair. Thus, the above three experiments nicely demonstrate Newton's law of motion.